Good morning, Miss. Our group is going to discuss about the topic of integration. My name is Privin Alakipatiwan. My matrix number is 01 DKM2F1073, and I'm going to discuss about introduction and conclusion.
My name is Gopi Krishna Analaki Lachmanan and my matrix number 01 DKM22F1064, and I want to talk about example of application of integration in real life.
My name is Kailash Analaki Parameswaran. My matrix number is 01 DKM22F1075, and I and Sebas will be explaining the solutions.
Hello, my name is Sebastian Peters. My matrix number is 01 DKM22F1084.
Okay, for the introduction, the integration denotes the summation of discrete data. The integral is calculated to find the functions which will describe the area, volume, displacement that occurs due to a collection of small data which cannot be measured singularly. In a broad sense, in calculus, the idea of limit is used where algebra and geometry are implemented. The limits help us in the study of the result of points on a graph, such as how they get closer to each other until their distance is almost zero. We know that three are two major types of calculus. First one is differentiation calculus, integral calculus, and the concept of integration has developed to solve the following types of problems. To find the problem function when its derivatives are given. To find the area bounded by the graph of function under certain constraints. These two problems lead to the development of the concept called the integral calculus, which consists of definite and indefinite integral. In calculus, the concept of differentiating a function and integrating a function is linked using the theorem called the fundamental theorem of calculus.
So, example of application of integration in real life. A plaster molding to be made. The molding consists of two parts, a curved part and a rectangular part. The diagram shows a section of molding. The height of the curved part above the line AB at a distance x centimeter horizontal from A is given by y equals to x power of 3 minus 4x square plus 3x plus 2.2 for 0 less than equals to x less than equals to 2. The rectangular section of the molding has the dimensions shown in the diagram. The total length of the molding is 3.5 meter. Find the value of plaster required to make the molding. Curve area equals to integrate upper limit to lower limit 0 bracket x power of 3 minus 4x square plus 3x plus 2.2 bracket dx. So equals to bracket x over 4 power of 4 minus 4x over 3 power of 3 plus 3x over 2 plus 2.2x bracket upper limit 2 and lower limit 0 and equals to 16 over 4 minus 32 over 3 plus 12 over 2 plus 4.4 bracket minus 0. So equals to 4 minus 32 over 3 plus 6 plus 4.4. So answer is 3.733 centimeter square. So the total area 3.733 plus 20 equals to 23.733 centimeter square. So volume equals to cross section area times by length. So 2.3.733 times 350 equals to 8306 over 5 centimeter cube.
So the first question is, given the graph of a curve with equation y equals to x square plus 2x minus 2 and straight line y equals to x plus 4, determine the coordinate of the intersection point A and B. So at the intersection point, both the equations will be equivalent. So we get x square plus 2x minus 2 equals to x plus 4. And with that we get x square plus x minus 6 equals 0. Once we factorize the equation, we get bracket x minus 2 and bracket x plus 3 equals 0. So when we get our x value, which is x equals 2 and x equals negative 3. So when we substitute x equals 2 into the equation, we get y equals 6, making coordinate b 2 and 6. And when we substitute negative 3 into the equation, we get y equals to 1, making coordinate a negative 3 and 1.
So the second part of the question, is to determine the area bounded by a line y equals to x plus 4 and a curve y equals to x square plus 2x minus 2. So first of all, why we need to minus the area under the line with the area under the curve? Because area under the line is bigger than the area under the curve. So second of all, I chose the limit for the integration as the upper limit is 2 and the lower limit is negative 3. So to find the area under the graph, we need to minus the area under the line and the area under the curve. So the equation will be integration upper limit 2 and negative 3 x plus 4 minus integration upper limit 2 and lower limit negative 3 x square plus 2x minus 2. So after we integrate the equation, we will get x square over 2 plus 4x with the upper limit 2 and negative 3 and minus with x cube over 3 plus x square minus 2x with the same upper limit and lower limit as well. So we need to substitute the upper limit and lower limit value to get the final equation, which is 2 square over 2 plus 4 times with 2 minus negative 3 square over 2 plus 4 times negative 3 minus 2 cube over 3 plus 2 square minus 2 times 2 minus with negative 3 cube over 3 plus 2 times negative 3 minus 2. So after we substitute, we will get 10 plus 7.5 minus with 8 over 3 minus 6. So the final answer we will get 25 over 6 unit square, which is in point form is 20.83 unit square.
For the conclusion, by the end of this presentation, you will be able to master the mathematical technique to calculate the area under the curve using integration. There are multiple methods for integration, of which we explore integration by parts in the article. Here we derive its integration by parts formula and also understand its applications. Yeah.
So thanks to Ms. Liu for the guidance throughout the completion of this presentation, and thank you as well.
Thank you.
Thank you, miss.